Welcome everyone to this CWNP webinar. I want to get started right away so as not to take up too much of your time on the Friday before, well, I guess we could call it Christmas week coming up, right? It's that week when not a lot of people do not a lot of things. And I'm sure we're all looking forward to our time off. Whether we participate in the holidays or not, we get some time with family and friends, and so some exciting times coming up for all of us. And today what we're talking about is wireless tools outside of the 2.4 gigahertz and 5 gigahertz band. And the reason I wanted to talk about this month as we go into a new year is because we're now dealing with the reality in our wireless world of having to do more than just Wi-Fi. We're having to deal with the reality that there are non-Wi-Fi technologies that are making their way into our environments, and we have to be able to deal with them in some way. So I'm going to share with you some of the options that we have for provisioning our toolkit to be prepared for below 2.4 gigahertz, above 5 gigahertz. What do we do? What do we look at? Some tools can be very, very expensive, and we can also find less expensive tools that we can implement to get the job done. So many times you don't need the most expensive tool. Of course, if your company's willing to pay $15,000 to $20,000 for a handheld spectrum analyzer that does the full range from, say, 20 hertz through to 20 gigahertz, then phenomenal. But if they're not, you might want some other tools in your arsenal as well. Now, of course, as always, you can find us online. You can find CWNP on Twitter at CWNP and myself at Carpenter Tom, simply because at Tom Carpenter was already gone when I signed up many, many years ago. Of course, we're on the web at www.cwnp.com. Now, why do we need these tools? Well, one of the big drivers causing us to have to look at frequency bands outside of 2.4 and 5 gigahertz is the Internet of Things, IoT. And we can put any letter we want in front of IoT. We can put H there and say it's health IoT. We can put I there and say it's industrial IoT. Or we can put A there and say it's agricultural IoT. Or C, it's city IoT. Everybody wants to kind of grab the acronym and make it their own. But the key is that IoT is real, it's huge already, and it's going to become massive, literally going to become massive in the coming years. Now, the exciting thing is there's no prediction that Wi-Fi is going away. So all of the knowledge that you might have built, if you've been studying Wi-Fi with us, with vendors, in any way whatsoever, to learn everything you can about Wi-Fi, that knowledge is not going away. That's the first thing. The specific 802.11 knowledge is not going away. It's actually expected to grow by 3 to 5 percentage points of the market over the next couple of years. So it's interesting. And of course, all of that depends on what study and statistics you look at, right? We can always come up with a statistic to tell our story. The other thing is that as you study Wi-Fi, particularly if you've been studying with CWNP, you've had to study underneath the hood. You've had to look at how wireless communications work. So you've studied things like modulation and radio frequency and antennas and chipsets and all of these different things. Well, guess what? All of that stuff applies even if I'm not in 2.4 or 5 gigahertz or even 60 gigahertz Wi-Fi. So the point is, whatever it is that I'm using, if it's radio frequency based, I'm using RF, right? So the factors of signal strength and signal to noise ratio, signal to interference and noise ratio, and RSSI, all these things, they still apply, okay? So the knowledge you've acquired rolls over, simply functioning in a different frequency, which of course has different responsiveness in the real world. So what bands are we talking about? Well, the 800 and 900 megahertz bands are very common for IoT. Things like ZWave and long range or LoRa use that frequency range, and others as well. 6 gigahertz is coming. We're going to see more things operating there, maybe even some Wi-Fi. 400 megahertz is used sometimes as well. So different parts of the world might use the 400 megahertz range. And these are just some samples. So they're very common frequency bands used by and for IoT. Now, we are considered wireless technicians, wireless professionals, wireless experts, the go-to wireless person, the person who knows more about wireless in our company than anyone else, right? And the thing is, Wi-Fi is not enough. Now, however, I do want to say Wi-Fi is most important in many businesses. There are entire enterprise campuses with thousands of employees on location where among wireless communications, other than, of course, their cell phone usage, but what the company deploys in many cases are 80 to 90% or more Wi-Fi. So there's no question Wi-Fi is most important in those types of businesses. But in industrial, agriculture, and many other industries, they're relying more and more on non-Wi-Fi because of the characteristics of these other technologies. More efficient use of a very limited spectrum, like in the 900 megahertz band. The reality that they can work over long distances. The fact that they only need a low data rate, and so it's fine that they work at those speeds. These things drive people into other frequency bands other than 2.4 and 5 gigahertz. Now, what I want to do is get out of slides. We're not just going to do death by slides today. And I want to show you some tools, some things that are available for you. But before we get into the tools themselves, I want to talk to you about a white paper that was very timely, just released in the last months recently, around September timeframe, if I remember right. And it's called Wi-Fi and LoRaWAN Deployment Synergies, Expanding Addressable Use Cases for the Internet of Things. Now, of course, the focus here is on Wi-Fi and LoRa. The LoRa Alliance was involved in creating the white paper, and of course, the Wireless Broadband Alliance. So given that WBA teamed up with the LoRa Alliance, you can expect that the major focus is on LoRa as an IoT solution and LoRaWAN as an IoT solution. But there's some really revealing and important things in this white paper. It's about 60 pages, so I would encourage you to download it. It's well worth reading. So if you're new to the non-Wi-Fi part of the wireless world and you want to learn more about it, this is really a phenomenal place to start. You're going to get business perspectives. You're going to see different industries and how they might utilize these technologies. And you're going to get comparison of a lot of different technologies as well. So it's a really good white paper for someone that is trying to understand what all of the things are out there in the IoT space. I really, really encourage you to get your hands on this and read through it. And you can find it, of course, at the LoRa Alliance website at LoRa-alliance.org. Now, as we go down through here, the big things that I want to focus on are really in the areas of what's happening, what's going on in the industry. So when we come down, there are some really good research reports in this that give you an idea of exactly what's happening. So let me pull this up. All right, right here. So this is the first thing. I mentioned earlier, Wi-Fi is not going away, right? So the thing is that what you'll notice is Wi-Fi is actually expected to make up a greater percentage of the traffic in 2021 than it was consuming in 2016 by far, but even in 2020. So what you're seeing is a growth here over time. You can see that fixed Wi-Fi from mobile devices was at 8% back in 2016. That's expected to be 20% by 2021. And fixed Wi-Fi from Wi-Fi only devices was 33%. That's expected to be 26%. So that part has gone down. But if you take the 33 plus the 8, you come up with 41%, right? But then you look in 2021 and you've got 46%. So a 5-point increase by 2021 over 2016. So Wi-Fi percentage of usage, according to this report anyway, is not going down, it's going up. And that's an important thing to consider, that Wi-Fi is certainly not going away. Okay, so that's the first thing I wanted to draw your attention to. Here's an interesting thing about LoRaWAN. Now, LoRaWAN is the WAN side of LoRa. So LoRa, L-O-R-A, I tend to use my West Virginia accent and say Laura like a woman's name, but LoRa is the modulation that's used on the RF link. So it's radio to radio. But in order for the device to really get somewhere, it goes across the LoRaWAN. Okay. The LoRaWAN is accessed by a LoRa gateway that connects to the LoRaWAN. And this allows your devices to communicate with the cloud, to communicate back to your corporate offices, whatever it is that they're communicating with. There are over 100 countries with LoRaWAN deployments and 61% increase in network operators in the 12 months leading up to December 2018. So this doesn't even include 2019 yet and the growth that has been seen in 2019. The network operators are the people that are providing LoRaWAN connectivity so that your gateways can connect to the LoRaWAN and actually provide internet-based communications to clouds or any other end network destination. Here's an interesting study that we've got to investigate. Okay, so this came out in 2019, and their forecast is that LoRaWAN is expected to represent more than 50% of IoT low-power wide-area connections by 2021. So this is a very key thing and a good reason to study LoRa and LoRaWAN and get an understanding for what it's all about. So it's growing in use, and what you will notice is that by 2021, it's expected that actually more devices will connect to LoRaWAN than will connect to NB-IoT or LTE-M, certainly more than Sigfox. And that's obviously very important to keep in mind. So we've got these cellular technologies, which are going to be predicted anyway, very popular. So a lot of people are going to use them. That's the prediction, right? But the prediction is that more people will use LoRaWAN than the others. And there are several reasons for that, but the key thing to take away here is that certainly LoRa is an important protocol. So the question then is, well, where does LoRa work? What frequencies does it work in? If you know, you can feel free to type it into the question and answer section, but it's a very important thing to consider, because if we're going to be using this link technology, if we're going to be building with chirp modulation, which is what's used here, if we're going to be building RF links using this, we need to know what frequency the RF works in. Now, keep in mind the LoRaWAN, we're not worried about the frequency, right? That could be cellular backhaul. It could be some other type of connection. What we're worried about is the link between a sensor or an IoT device and the LoRa gateway. And that is going to be using some RF frequency. Well, okay. The most popular frequency band used is the 900 megahertz band. So this tells you something very important. It can work actually 400, 800, 900 megahertz. 900 megahertz seems to be the most popular that is in use right now, probably in part because of the regions that it's operating in. So what this tells you is that that band obviously is very important for the future of a wireless troubleshooter, someone who's going to be dealing with these various technologies. Now, again, I encourage you to go ahead and download this white paper. I'm only up to page 16 of more than 60, so clearly there's a lot of information in here. Great insights. I really enjoyed this. It's one of the few white papers I've read in 2019 that I was done with it and was completely 100% satisfied that I had read it, that it was valuable to me. So I think you'll enjoy this particular white paper. Remember, what you're looking for is Wi-Fi and LoRaWAN deployment synergies, expanding addressable use cases for the Internet of Things. And you can find it at LoRa-alliance.org. Now, all right, let's talk about then, what are some tools we can use? So spectrum analysis is one of the things that we commonly need to do, right? So here's a company, Aronia, which makes some really good spectrum analyzers. And you can see that they have here a nice spectrum handheld analyzer that goes from 9 kilohertz to 20 gigahertz, with the exception of some of the, the 60 gigahertz things in Wi-Fi, as well as in 5G eventually, things like that. It's going to give us a lot of the spectrum, right? 6 gigahertz, 5 gigahertz, 2.4, 900 megahertz, 800, 400, all of that's going to be covered by this device. So definitely a device that could meet your needs. Wouldn't you love to have this device? Interestingly, I emailed them and asked them if they would send me one for free, and I never heard back. Well, there's a reason for that. Let me show you something. Here's your price sheet. I love price sheets like this, okay? So this is the Spectran V5 price list. And you can get the handheld analyzer. You can get a mobile unit that looks like a military grade component device there. Okay, so this is the price list. Let's see how much it costs. The answer to how much it costs is ask for quote. Now, why is that? Well, let me just show you. Right here's your options. Please note that not all options are available for each instrument. Please contact us for further details. So you've got an option, ultra low phase noise. Okay, that's going to cost you a bit. High precision time base, that's going to cost you a bit. 160 megahertz real-time bandwidth, all right? These are features. Okay, so think of this like I'm buying a car, right? And when I buy a car, I can get electric seats. I can get heated seats, cooled seats. I can get a sunroof. I can get electric windows. I can get a CD player and Bluetooth, and the list goes on, right? But I can also get the streamlined one without all the features, and it costs a lot less. Okay, all these prices you see down here at the bottom, those are not for the device. Those are for extra things you can get for the device if they happen to be available for it. So the extra things can cost ranging from $499 to $1,998. That's the extra things. What's the actual price? Well, if you do some searching around online, you can find some stores that are actually giving you prices for this, and they range from 15 to 22K. All right. So, and that's in US dollars. So $15,000 to $22,000. Obviously, it's not an inexpensive device. This is a professional tool. It's more than a professional tool. It's an uber professional tool. And there are many experts out there that wouldn't have the budget for this. Even if their company wanted to buy their tools, they still wouldn't buy them this. So it's very important to keep in mind what's available to you. Now, would I want this tool if every day I was troubleshooting these different types of networks running in 900 megahertz, 800, 400? Yes, I'd want this tool. And because it sweeps the entire spectrum, and it is a spectrum analyzer, meaning that it doesn't matter if there are new versions of the protocol, as long as they still work somewhere from 20 to 20, right? So somewhere up to 20 gigahertz, as long as they work in that space, this spectrum analyzer will show me the RF, because that's what it shows me is RF. So this is a definite power tool and one you could get. What are my other options? Well, your other options are really twofold. Finding tools that you can acquire outside of your vendor, or using the monitoring solutions that might be built into your IoT networking solution to do some troubleshooting there. They may not give you spectrum analysis, but they might give you protocol analysis and other troubleshooting tools as well. For example, there's a company called Monit, and they sell wireless sensors. So you can build out an entire wireless sensor network. Now, if you're not familiar with wireless sensors, CWSA is the introductory course that introduces you to sensors. And you would just need to know for now that they're able to detect things about their environment: temperature, the presence or absence of light, movement, fluid levels in tanks, the existence of a current or the lack of the existence of an electrical current. Contact sensors. So is the sensor in contact with the other component of the sensor, like a window is closed versus open? All right, so all of these are sensors. And the sensors can connect wirelessly back to a gateway that connects to the Monit cloud. So the Monit cloud is called iMonit, and we're looking at the iMonit user guide. So this is an example of a vendor interface that might be available to you to actually monitor what's going on in your network. And if we were to go through this document, you would find that there are various reports of sensors and gateways. So you can look at them, you can see their status, and discover what condition they might be in at any given time. You can see messages from the gateway and from sensors, and be able to analyze and troubleshoot what might be happening. Okay, so that's the basic tools that might be available. Now, you can also, instead of just relying on what vendors provide, you can get third-party tools. So a good example of that is the ZWave Toolbox. I've talked about this before in a YouTube video, the ZWave Toolbox, product code ZWP-TBX. is $149. Now, it says save 40%. For about 4 months now, I've been seeing that this is still $149. So I don't know how long they're going to keep it there. It may be permanent, but for now anyway, it's $149 USD. And what this little box does, so you take this box and you can use it in one of two ways. You can plug it into power, and you'll notice it's kind of hard to see. This screenshot is not really a good quality screenshot, but there's a Wi-Fi indicator letting you know that Wi-Fi is functioning. And when Wi-Fi is functioning, it'll light up, and you can simply connect your phone to this and then navigate to the IP address and gain access to it. The other thing is you'll notice there's an Ethernet port right here. So I can plug this into my network, my Ethernet network, in the location where I want to do analysis, and it'll power on. If not through PoE, then it'll power on through the power plug or maybe an external battery that I might use to run it or something like that. You'll notice there's USB here. I can power it through a USB battery. Okay, so I can get this up and running. And once it's up and running, I connect either through Wi-Fi or I connect through the Ethernet connection, either one, and then I can actually work with the tool. Now, the product comes with some basic documentation to walk you through what you can actually do with it. And so you can see here the connectivity with the device. We have the Ethernet cable run into a home router. Tablets can connect via Wi-Fi. And of course, we have a ZWave controller somewhere out there that we're going to connect this device to. Now, I don't actually have a ZWave controller connected to mine right at this time, so we won't see that part of it, but that's something that can be done. And so either through the Ethernet cable or through the Wi-Fi, you can connect in. All right. Now, with that said, we can see then that we can log into the interface. And once we log in, we have access to various reports. So let me go over here and show you a bit of what this might look like. So here we see the network health report screen. You can obviously update the firmware, and we can see other interfaces. So you have the ability to test connectivity with a connection tester. You have a network health tester and so forth. Well, instead of just talking about it here, let's go ahead and take a look. I'm connected to mine right here. And so you can see, first of all, if we go to settings, you can set up a user profile. It basically allows you to have different users saved in the device to log in. By default, you log on as the user named user with a password of password, all lowercase. And you'll see I can set the time, and I can configure my network. This could be important because notice when you go into network, the default network settings are 192.168.100.1. When the device implements a wireless network, that is the IP address of the wireless network, okay? And the subnet mask. So if you are concerned of conflicts with that IP address, you might need to change it. And you can pick the Wi-Fi channel. You'll notice it's 2.4 gigahertz only. This thing doesn't monitor 2.4 gigahertz, and it's not going to hurt performance for it to run in 2.4 gigahertz because of what you're actually doing with it. So you can change the network settings if you desire. You can check for firmware updates. You can use the tool selector, but there's no reason. It's just a kind of bad way to get to all the stuff that's already over here to the left. So when you go into the network health, you've got testers. And so you have a control panel that simply lists the device that you're working with. We have the ZWave Toolbox here, and there's a network health tester. I'm not actually connected to a ZWave network, so I can't test it, but it would simply give me green if it's able to connect. There's a simple connection tester, same thing. It's going to show me the route followed to get to the end device and the time that I ran the test. So simple tools there, but again, I'm not connected to a ZWave network, so I can't use it. We have the maps. So this would show me my map of my ZWave network, which could be useful. And I could see a connection grid, which shows me the path of the connections through the ZWave network. Under utils, I have a finder. So this can be useful if you're trying to locate a particular device, then you can do that with the finder. And it also just shows me the background RSSI. If I run this, it'll do a quick scan and then show me for the entire band from 900.8 megahertz to about 918 megahertz. It'll show me the entire band here and what we're looking at. So you can see that. And That is the RSSI and dBm. This is not looking at a particular signal, by the way. Okay, so this is looking at the RF energy out in that space. Now I also have my ZWave analyzers. So there's a packet analyzer. Now, of course, this only works with ZWave. So if you have a ZWave network, what this is going to do is it's going to report to you the signal strength of the devices, the source, the route, and the destination, and what was the ZWave command that was actually executed. So you're not looking at the ones and zeros, you're looking at a summary of what the command actually was, which can still be very useful for troubleshooting purposes. No sense in playing or running this here because there's nothing on my network to detect. When I go to the site survey, if I ran this, this would show me the ZWave networks and devices and signal strengths that are out there. That could help me to know what's going on in that space with ZWave and whether I could use it or not. So again, the packet analyzer, the site survey, fairly restricted to just ZWave analysis and use. The next one, though, is not. This is the spectrum analyzer. The spectrum analyzer looks at the RF spectrum. So if I click capture here, it'll take some time to get a picture of what's going on in the RF spectrum. And then once it's done, I'll be able to take a look at what's taking place in 900 megahertz. Now, the beauty of this is, notice it goes from 900.8 all the way through to 919.8. So I'm not just looking at the channels used by ZWave, which is right here and right here, but I'm using or looking at all of that roughly 20 megahertz of space, 19 megahertz to be more precise, that is there in the 900 megahertz band. So what have I got here? Well, basically I've got a 900 megahertz spectrum analyzer. Okay. So I do have some noise floor here because of some things going on in my environment, but you can see what the spectrum analyzer actually looks like. So this was how much? $149. Is it as good as the $15,000 to $22,000 device? Absolutely not. But it can be very useful for some basic analysis and troubleshooting, trying to figure out what might be going on in a space, what frequency use might be there and so forth before you deploy a network. So it can certainly be very useful in that way. Of course, there is also help, but there's one thing I always want to point out. Let me see if I can find this here briefly. This is a very important thing to know. Okay, right here. So here we're looking at the spectrum analyzer, and you can see, by the way, right here, you can actually see signal going on in the space a little more clearly in their screenshot. But right here, each time the toolbox is changed from the network health tool or packet analyzer to spectrum analyzer and or back, the ZWave chip is reconfigured. The chip has a life of approximately 10,000 changes. So please think ahead for planning to avoid reconfiguring the chip back and forth needlessly. We recommend starting from the network health tester. In other words, they expect you to be able to switch to spectrum or from spectrum analysis up to 10,000 times. So best case scenario, we start up the device, we switch to spectrum, we look at it, we switch back to network health testing, and we've just lost 2. That particular process could be done 5,000 times. If I did it 10 times a day, it's only going to last me 500 days or about a year and a half, right? Okay. Now, I don't think most of us would be doing it 10 times a day, 7 days a week, but the point is, I just want to point that out. I want you to know this is a disclaimer they have in their own documentation about the life expectancy of this particular spectrum analyzer because of the reconfiguration of the ZWave chip. Okay. Now, let me state before I move on to RF Explorer that there is another option, okay? So you can get modules, riser cards, if you will, for things like the various different small form factor computers, like the Raspberry Pi, that allow you to do LoRa, that allow you to do Zigbee, that allow you to do various different IoT protocols. With those, you do have the ability to build your own analyzers, okay? So you may be familiar that in the wireless community, there's something called the WLAN Pi, right? And the wireless LAN Pi is a Raspberry Pi that does wireless analysis. Why is it doing wireless analysis? Because it's using wireless or Wi-Fi rather, Wi-Fi analysis. Because it's using a Wi-Fi connection and Wi-Fi radio. The same basic thing can be built for any protocol as long as there's a module available for the Raspberry Pi or the Arduino or whatever it is you want to use, okay? So you can certainly build on a budget very inexpensive, let's say under $300 devices, but you're going to have to do all the coding, right? You're going to have to build the code or start a new project like the Wireless LAN Pi and get people working together to come up with a solution. But the point is that those kinds of tools could be built as well, and I'm sure they will be over time. And once they're available, the ideal thing to me would be able to get a Raspberry Pi, get a Wi-Fi module, get a Zigbee module, get a LoRa module, what have you, all these different modules, Bluetooth, etc., and then get some code blocks that can be abstracted away from what the underlying technology is. So I can say, just tell me the signal strength, tell me the packet contents, so I can abstract all that and then just have access to any of these technologies that I want through some type of a layer that might be there, okay? Kind of like if you studied Windows in the past, the old hardware abstraction layer that was in Windows NT still is. Windows NT through to modern day Windows servers and even Windows 10 systems, which sits between the hardware and the operating system, right? So if we had an abstraction layer that could be custom built for each of these different protocols, then we could have higher level things that simply pull that information out, which can be very useful. And I'm sure we're going to see concepts like that built over time. Who knows? Maybe someone who's talking right now is even working on it. Okay, so here we have the RF Explorer, another option for you for spectrum analysis. Now, the RF Explorer comes in a lot of different forms. It is not a high-resolution spectrum analyzer, but it's plenty enough for a lot of IoT things that work in 900 megahertz, 800 megahertz, and so forth, because they really have very narrow channels, and they are, in many cases, some of the only things working within the space. But still, it allows you to do that spectrum analysis. Now, you've got a screen that is a very low res on the actual handheld device itself. You see a still of the video there of what that screen looks like. And then you can connect it to your computer with USB and then get a little better look of the spectrum. So you get a little more resolution in your view. So there's more resolution than what this little screen allows you to see on the RF Explorer is what I'm saying. It's still not as high resolution as something like the Ekahau Sidekick is for Wi-Fi, or Air Magnet Spectrum XT for Wi-Fi, or the old Cognio cards for Wi-Fi. It's still not that same level of resolution, but it is getting more resolution than the little screen makes it seem. And to connect it to a mobile phone or a laptop, you get a little better picture of what that resolution is. Now, it is very important to know it comes in different models. So, for example, if you really want to be able to do all of that low frequency stuff, and that's all, maybe you've already got your tools for 2.4 and 5 gigahertz and you're not worried about things above 5 gigahertz, then the RF Explorer WSUB1G may be enough for you. It goes from 240 megahertz to 960 megahertz. You can also get the WSUB1G Plus, which goes lower, 50 kilohertz up to 960 megahertz. So that kind of covers that whole sub 1G area and can be very useful if that's what you're focusing on. You just want a tool for that space, then that one could be enough for you. And we can see then that model does that. Now, if we scroll down, you can see that model is 165. If you don't care about going down to 50 kilohertz and just 240 960 megahertz is enough, then it's only 129. Okay. So 165 for the WSUB1G Plus, 50 kilohertz to 960 megahertz. All right. Frequency resolution is 1 kilohertz in all of these, by the way, just so you know what the frequency resolution actually is. Now, the other option, if you don't already have a tool that covers the Wi-Fi space and others, is you could go with the RF Explorer 6G combo. Now, this one is still very inexpensive in perspective of what these things usually cost, $365 US. And you can see that what it does is from 15 up to 2700 megahertz. And 4850 to 6100 megahertz, or from 4.8 gigahertz to 6.1 gigahertz. And so you're going to get your 802.11 gigahertz band covered in here, as well as some other bands north of that, you might say. You're going to get your 2.4 gigahertz band covered here, as well as 900 megahertz, 400 megahertz, 800 megahertz, all of that covered. So if you need basic spectrum analysis and you don't want to break the budget, I don't know of a better tool in a price point that covers the space for you. So it's a good price point for those that really want to get a tool that can at least help them do some basic RF troubleshooting. And this is on the air, so it's not like I'm connecting this with a cable to a device and looking at the signal. No, this is pulling it from the air is what it's actually doing, right? That's why you've got your little antenna here and so forth. So definitely a tool to take a look at. That's what we had scheduled to cover today. So at this point, I'd like to say thank you for attending the webinar as we discussed a little bit about these tools outside of the 2.4 and 5 gigahertz Wi-Fi space. There are more tools out there as well. We'll be posting this webinar to our YouTube channel, CWNP TV. And so I would encourage you, if you know of other tools that are great, once this posts on YouTube, if you're subscribed, you'll get a notification. And go out there and comment. Share some tools that you know about. If you're watching it on YouTube archived right now, then comment below. Let people know tools that you've encountered, even if they're very expensive. List the tool and tell us what it's good for. All of us in the community are always wanting to know more about the tools that are available to us that can help us to do our jobs more effectively. Thank you very much for attending today.